start this. The like that personality stuff last time, I wanted to just go over a little bit of it and like different things that we found on there. So like hopefully y'all are somewhat interested in this. So this equation right here, this internal consistency type of stuff, like on the final exam, you'll probably need to like know this and come back to it. And like after we're done going through this, we'll go into the placebos. Really, if the Cronbach alpha, which we're calculating, like the internal consistency, how well people are answering questions within a particular construct. If it isn't at least a 0.8, it's probably bad. So how we can calculate that is number of items, or like number of components, so 5 items in the personality. And then in Excel, which I put everything in Excel and I uploaded it to Canvas for us to look at, sum of variance is divided by the total score variance. So like I'm just going to pull up the Excel document and we're going to like look at that. If like I think it's really cool to see, really. So here can you all see this somewhat okay? Somewhat okay? At least a little bit, right? Okay, so like down here, I've got like females and males, and overall, like I'm gonna go to this sheet 2 here in a little bit. I just entered everyone's stuff, and so red, that's extroversion. Yellow, that is, I think it was either conscientiousness or agreeableness. Okay, it was agreeableness. Then baby blue was conscientiousness. So like I just entered like a lot of equations to make all of that work. Like actually entering all of y'all's stuff was relatively fast and it was pretty cool. Something weird that I didn't notice, we have a lot more guys in this class than we have girls. So I guess I didn't notice that since all of y'all are like up here and I look at y'all the most. So that's kind of strange. But like one of the biggest things I realized whenever I told y'all to like reverse score things, males are horrible at following directions. So there's only a couple of things that I wanted you to reverse score, and like a lot of you reverse scored like everything. So that made it a little bit longer for me to actually end up doing. But so this overall, like over here on this side, this is all females. And if we go on to over here, this is all males. So like quite a few more males than we have females. I got like some averages, standard deviations, and lastly I did like a t-test comparing how how women viewed that they were, like on how much of a good person they were versus men. So like right here, on average just a little bit, men viewed themselves as a little bit more of a better person than women did. So that was kind of interesting. Like really, this class was very bizarre to me. A lot of people put 7s in like a good person, which like was a little bit bizarre. Or like remember, is a 1 to 7 scale. So it's and it wasn't reverse scored. So it's it's Ryan, did you laugh at that or did you just? Oh, okay. Yeah. Okay. Cool. Thank you. So like this here t-test. So like whenever you do like your results for your papers, you're probably gonna have to do some t-tests or anything, and like that gives us our p-value. So if you remember, a p-value of 0.05 is significant. So if it's above that, not significant. So something that we can look here, 6.2 for good person for women, 6.4 for a good person for men, and the variance there being 0.6 for men and 0.95 for women. These are virtually identical, right? Like we could say that like men are slightly higher, but not really. The t-test indicates that 0.65, meaning that these two numbers are virtually the same. Does that make sense to everybody? That like how women answered good person, how males answered how good of a person they were, virtually the same. GPA, this one's somewhat common, like the women in the class had a slightly higher GPA than the males did. However, if you look at that, this value right here, that t-test, that 0.25, it's not significant. So it's not a 0.5 or anything like that. So really, everyone's GPA in here is approximately about the same. Or at least whenever I compare males and females. Minutes of exercise per week, like males, 207, females, about 2 hours. So the variance was high enough to where the t-test didn't pan out to where they were different. So a 0.2 on there. So that's closer to a 0.05, but it's not a 0.05. So I can't say that males statistically significantly exercise any more than women do in here. Does that make sense to y'all? Right? Okay. Now this extroversion piece, like I just summed the scores for extroversion. So we got like a 23.7 average for females and a 22.8 one for males. So like here, really they're about the same. Like the variance is both around 5, so standard deviation, and then that t-test being a 0.7, meaning that they're virtually the same thing. So like typically, like if we test like a lot more people, women tend to be a little bit higher in extroversion than men do on like some occasions, but not in here, not in here. So it's at least not statistically. Now agreeableness, kind of similar thing going on here. Like really, this one was fairly strange. Like it got pretty close to being significant whenever we're like actually comparing like these two. So the women in here, agreeableness, like score of all the different items, summing them together, almost a 24, whereas like for the men, it was like just over a 26. So statistically not different, but you know, numerically, like males being like slightly more agreeable as they rate themselves in here, which you know is kind of interesting, I think, right? Right? Do y'all find that interesting? No? Okay. Huh? I like how you placate me. That's funny. Okay. And conscientiousness. Here, this one, males were and females were approximately the same. Now for like these Cronbach alphas, I added up the number of items and the sum of variances and the variance totals and things, which like are actually a lot easier to calculate than you think. So like here, let's look at the females really quick. Like how I get variance, I actually just enter this equation of like within Excel you just write like var p, which is a type of like variance measure. So really just seeing at how like consistent everyone's answering everything. So like I sum the item variances, then the variances of the total scores, and then I get a Cronbach alpha number of approximately that. So here, there's something about the survey that we did to where for women, extroversion and conscientiousness, we had really low Cronbach alphas, meaning that there was a lot of variance in how like the women answered how they were about extroversion and conscientiousness. Now the agreeableness, that Cronbach alpha being a 0.88, so a 0.8 means it's good, right? So those questions, like all the women answered fairly consistently. Does that make sense? So if we were going to do this study again, we would have to go back and look at the items of extroversion and conscientiousness and be like, oh crap, like which items are making people answer in a really odd way? And then we would throw those out and try to like ask like extroversion or conscientiousness questions a different way. So that's like how scientists would do this type of thing. Now, like we would, but like we don't really have time. Now, here with the guys, on like this far side right here, the extroversion was the closest to meeting our 0.8 Cronbach alpha. So like really, it overall like these aren't terrible scores, but they're kind of bad. Like really, like how the guys answered stuff in this class, like pretty much it wasn't all over the place, but there was a lot of variance within extroversion, agreeableness, and conscientiousness. So like kind of interesting, y'all, right? So like for whatever reason, how the women were answering the agreeableness questions, they answered them more consistently than how anybody else answered any other flavor of question. So that's yeah, I don't know. I think that's kind of cool, right? So like that's what like a scientist would do with all of this stuff. So like I don't know. I think it's fairly cool and interesting and stuff. All right. So why is it doing that? Well, I don't know why it's doing that. But that's okay. We'll just roll with it. Maybe that'll go away. So the correlation stuff. Like, how many of y'all read the astrology signs and correlation thing? Okay, Stefan did. Ryan. Okay. Abrielle. Okay, cool. So like, go back and read the paper. It's like I'm gonna read a lot of it to you, like while I'm up here. The paper is meant to be a joke, so like it's pretty interesting. Like, does anyone know who Neil deGrasse Tyson is? Right, okay. So he, like on one of his lectures, he gives this whole explanation for why astrology signs don't really make any sense and like why they're like kind of ridiculous. You shouldn't think about anything with them, at least scientifically. Even though, one thing like I will say, in my family, my Aunt Jane, is the person I'm the closest with, and she's really into astrology. Like anytime I like meet a girl or meet a friend or anything, like I figure out her birthday and I tell it to her, and she always has loads of fun with it. Which like is terrible, but like it gives her and I something to talk about so that I don't lose all of my family members. But yeah, oh yeah, yeah, definitely. Like just going back with this correlation stuff. Hopefully, all of you like remember how this works. So the correlations being strong, negative, weak, positive. So -1 to 1, 0.2, 0.4, 0.46, all of this type of stuff. The thing here that I'm trying to have you understand from the paper, it's kind of about correlations, but it's really about associations with something that doesn't actually mean anything else. So, like I put this up online, so like check it out. So astrology signs and personality traits. So hopefully everyone do all of y'all know all of the astrology signs like Virgo, Gemini, like Capricorn, all of that type of stuff? Huh? Well, yeah, it's really with your birthday and like where the stars are whenever you're born and stuff. But like here, like I just want y'all to guess. Funny and generous. What astrology sign is that? Virgo? Maybe. Ah, it's Sagittarius. You know, so like if this was a pop quiz, you'd suck right now. It's but like I'm sorry, I shouldn't say it like that. Wise and artistic. Who's wise and artistic? Wait, did you just say Virgo a second ago? Man, come on, dude. It's Pisces. Get it together. Yeah, it's I don't know, like it might be. Like Virgo and Pisces have a similar amount of letters versus Sagittarius. So like that's close. I would give you some points. Sensitive and loyal. What do y'all think? Aquarius, I think you're actually right. Oh no, Cancer. Oh no, good job. Wait, are you looking it up on? I actually knew that one. Oh, you did? Okay, okay, cool. Like strong and reliable. Leo? Ah, Taurus. Okay, so right. It's how about this last one? Serious and strong. Okay, I think Leo for this. You think Leo? Oh, Virgo, Virgo. It's totally a Virgo, right? So like there we go with that. Now like a lot of people like actually believe this stuff, and I don't know, like hey, like don't look up stuff.
Astrology signs came up astro-stealing signs.
Astro-stealing signs, like the Houston Astros? Well, okay, yeah, that's how we should do this. Okay, so like let's look at the paper a little bit. So this paper came out in 2006, and they actually acquired a bunch of data. Like it's all in Canada, around like Toronto, and like here's the point of it. Like the point is within the title. So testing multiple statistical hypotheses and resulting in spurious associations. So spurious means that there's a relationship there, but it doesn't cause one thing or another. So a study of astrological signs and health. Like these people, like Peter Austin and Janet, they must have like, as far as scientists go, this is as funny as we get. Right, so like this, that's why I was having y'all read this. So like this abstract, like since so many of you didn't read it, I'm just going to read the abstract to you. So the objective is to illustrate how multiple hypothesis testing can produce associations with no clinical plausibility. So like study design and setting, they conducted a study of 10 million, so like almost 10.5 million residents of Ontario aged between 18 and 100 years old in the year 2000. So residents were randomly assigned to equally sized derivation and validation cohorts. So they cut these people in half, and they like looked up their astrology signs, and they more or less figured out what diseases were the most common for each astrology sign. So they had come up with like two diseases or two like ailments of some sort, and classified according to their astrological sign using derivation cohorts. They searched through 223 of the most common diagnoses. Can you all think of 223 reasons to go to the hospital? Can you really? Like, I mean, I don't know, like toothache, being mad, I don't know. Like that, those are the only reasons I would ever go. Um, uh, I what I said didn't matter, right? So yeah, that was for me. Um, uh, s- so 223 reasons until they identified two for which subjects born under one astrological sign had a significantly higher probability, based on the p-value of like getting that ailment being than being born under other signs. So they tested 24 associations. So like there's 12 astrology signs. So like two per each, right? That's how that math works. Um, and like then in the derivation cohort to like generate ideas, and then they had the other 5 million people essentially validate that. So after they did all of that, there were only two things that actually came away in like all the 10 million people in like this 5 million statistics, and then the other 5 million statistics. So what was it? Leo? So is anyone a Leo in here? Oh, okay, cool. Like
That's all I have for a Leo.
metal. All right. So they have a higher probability of gastrointestinal hemorrhage. So, all right, while Sagittarius had a higher probability of humerus fracture. Is anyone Sagittarius in here? Right? No, only me. Okay, cool. And like I've never broken my humerus, right? Oh no, I will never break my humerus because my arms are invincible. Obviously, I don't care. It's no, like actually I have DEXA scans. I have really thick humeruses. Now like other things, they could break, but not my humeri. So compared to like everything else.
Femur would break more like you would more likely break your femur than your humerus.
Yeah, I've got thick arm bones. Like they're really heavy. Like I walk around really, whatever. Moving on.
Wasn't it you last year in 415 that said that big bones is not a thing? Or big skeleton.
Yes,
Big
yes.
boned isn't a thing.
Yes,
so
big boned isn't a thing, but bone mineral density is a completely different thing. You can have extremely high density in bones, but like my skeleton only weighs like 6 pounds or whatever, so like being big boned isn't really a thing. But like I can have like really high like bone mineral content in them. This is another class. I shouldn't be talking about this. Okay. So like in the introduction, here's something that like I found kind of interesting. This is how they started off. The Second International Study of Infarct Survival, which is called the ISIS-2. So ISIS, anybody like think that that's like right? Terrible time, right? But like keep in mind this was in 2006, so like they were only beginning then. Demonstrated that the use of aspirin during the acute phase of acute myocardial infarction heart attack reduced mortality in a group of more than 17,000 patients. But a subgroup analysis showed that demonstrated that aspirin increased mortality of patients born under the astrological sign of Gemini or Libra. So, like, effectively, that's a joke, right? Like there's no relationship there. But like there are papers that show these types of things, and on like the next paragraph, it shows something like, well, like are Leos, are they really big-hearted? So do they have like more left ventricular hypertrophy than other individuals? These things have been measured. It's and like there's really no relationship there. So the purpose of the study was to demonstrate the pitfalls of multiple hypotheses testing. And conducting analysis without specified hypotheses. So, like they hypothesized that they could generate numerous statistically significant associations, but these would be neither reproducible nor biologically plausible. For illustrative purposes, they studied like astrology signs and all of these different cohorts and things. So the methods that they used, like in the abstract, I kind of talked about this a little bit, but they looked at over 10 million people. If we did a study on over 10 million people, do you think we would find something? We should, right? Because like 10 million people, that takes forever to look at, right? So like these people clearly had a lot of time. But like then again, it's in Ontario, so around Toronto. So like, what do they know about anything? Then they randomly assign the people into a derivation cohort, meaning that derivation, they're trying to generate ideas and then test it in a validation cohort. So effectively, they're trying to generate a hypothesis and then test it in the other 5 million people or so. Like they were looking at it for like 2 diagnoses, and here effectively is what they came away with. Like, all right, so relative risk, hopefully you remember how all this works, like epidemiology faces its limits. So I want to go through a couple of these just so you understand how nonsensical whenever someone says there's a 20% increase of heart attack from whatever. Okay, so like let's look at the first one. So if you are an Aries, there is a 27% increased likelihood, so 1.27, that relative risk, if you're an Aries, if that's your sun sign, as they would say, that you would have other disorders of bone and cartilage. Okay, so do y'all remember whenever it was like eggs, 26% increased risk of stroke? Okay, so if you're an Aries, 27% increased risk of bone and cartilage disorders. Well, it's,
I'm an Aries, sorry.
that's not the point of this.
Okay.
The point is, this is a lie. So, like, yeah, like this is nonsense. That's the point of all of this. Do all of y'all understand, like, this entire lecture is a joke and trying to make you understand that whenever someone says there's a 30% increased risk of anything, that you should not listen to them. Like, it doesn't make sense because we're making associations with astrology signs and health outcomes. Right? That's the point of this. So you saying like, oh, like you're an Aries, no, this is ridiculous, right? Okay, so like, right, like let's look at the like the biggest one. If you're a Scorpio, is anyone a Scorpio in here? Right, Nick? Okay, so there's an 80% increased risk, 80% increased risk that you're going to get lymphoid leukemia, just based on your sign. Well, I wasn't going to say that one because that's I don't want to say that on tape. But like 80, like no, let's hide this. That 80% increased risk, right? 80%. If we showed 80% increased risk of anything in any other study, we would talk about it being a big deal, right? But here, it's not. Like this is clearly nonsense, right? Like do all of y'all see this, right? Yeah. It's it's coincidence. And like if we get enough people in a particular study, then yeah, like obviously this can happen. Like, which one was my favorite one? Do y'all see the Capricorn one, this 29% increase? Other ill-defined and unknown causes or morbidity and mortality.
And forced?
Well, right, another one I didn't want to say, right? It's but like that one, so there's a 30% increased risk of other ill-defined and unknown causes, like or morbidity and mortality. Does anyone know what that is? Yeah, no, I mean, but like it's like ill-defined, so like they died, but we don't know how, right? Or they got a disease, but we don't know how, right? Like, yeah, don't go to the doctor in Toronto, I guess. Yeah, well, I mean, you know, it's no comment, I guess. So like, what they came away with after all that is said and done, like this table, only 2 things actually ended up like staying, and I already said them. So the Leo gastrointestinal hemorrhage, that showed up in the cohort that they derived these ideas from, and in the validation cohort. And the Sagittarius, the fracture of the humerus, that showed up in both as well. The rest of these didn't. All of this is just from the cohort that they derived the information from. And like I don't know, like I just like having this information in my head. Like if you're a Scorpio, 80% increased risk of lymphoid leukemia. That one is just like really striking to me because that sounds like it's a thing, but it's not, right? So you can go anytime you want. Okay. So problems of this that like they talked about in the paper, and I want you to go back and like look at this. So multiple hypothesis testing, we talked about that a little bit before. If you don't correct for how many hypotheses or how many dependent variables that you have, then that drastically inflates the chance of us getting a, what is it? like a significant, like a false positive, like a significant result that isn't actually real. Adjusting p-values for multiple comparisons, like if we have numerous comparisons, we can't use the 0.05 anymore. We need a 0.000005, something like that, to like make sure that this isn't just like spurious nonsense correlations. Probably the section in the discussion that was, I don't know, like I wish they would have written more on this, but this is the most important part. Importance of biological plausibility. If there's no reason to think that there's any relationship between this one thing and this other thing, well, then there's probably not any relationship between it. So like a biological plausibility, like where, I don't know, where the like Little Dipper is in the sky whenever you're born, is there any reason to think that that's going to affect your health for the rest of your life? Now, I mean, like, I'm open to it. It certainly could happen, but like they would have shown some studies, and like it's never been replicated or shown. Subgroup analyses, data mining, things like this. So this multiple hypothesis testing, like here's kind of like an idea that I showed y'all before with like say if we have 20 hypotheses, and I'm going to try to go a little bit faster. Do y'all remember this equation right here? The 1 minus, like in parentheses, 1 minus 0.05 parentheses to the power of however many dependent variables that you have? Y'all remember this? Right, so this is the likelihood of getting at least one significant result that isn't actually significant. So say we have like 20 hypotheses, right? So I could have done 24, I just didn't. I just picked 20 because like it went into my calculator really fast. If we had 20 different dependent variables or 20 different hypotheses, there's a 64% chance likelihood that if I run an experiment, at least one of them will be statistically significant. Does that make sense to all of you? Right? So like whenever we're reading these method sections and there's statistical analysis, if they don't say that they corrected for multiple hypotheses, they should. They should, but like just most people don't. So like that leads to like a lot of this type of stuff. So like remember 0.05, this means that there is a 5% chance that the results are due to random chance. So that one before in the like 20, like to the power of 20, like 20 dependent variables, that means that there's a 64% chance that's due to random chance, or that like we're going to get a lot of these like type 1 errors, like false positives. So like the likelihood that we're going to measure something and we're going to call it true with our instrumentation, and then it's actually going to be false, is drastically inflated. Does this make sense to all of you? And like I'm trying to use this astrology thing to really like take home that point. Large N values, so like the N value, like the 10.6 million people that they had in the study, here's a particular relationship with N values and P values that I want you to know. This is what it looks like. So over here on this like left-hand axis, that's the P value. So P value being significance value more or less. And then down here at the bottom, that sample size, that's the N value. So what I want you to take away from this is that the larger your sample size, the higher the chance of a statistically significant p-value. Y'all good with that, right? So 10 million people being in the study, of course we're going to have a lot of significant things. Of course we will, right? Because 10 million people is so many people. Like this is kind of like the dilution effect that we were talking about before. Like more isn't always better. Sometimes more makes things worse. Y'all good with this? That makes sense? Moving on, and I think this is the last slide, so like I'm sure y'all are excited about that. So two like definitions that people do. Data mining. Data mining. So this is where people get really large data sets, get a lot of information, and then they start doing like different statistics on it. So data mining, it's the practice of examining large databases in order to generate new information. So effectively, that's what like those people with the astrology signs did. They had a large access to information, and they were just data mining, trying to find like different associations. Like whenever I was in grad school, there was something that people would always say. And they would say, sample the universe. So like try to get as many dependent variables as you possibly could, because you never know whenever one is going to be statistically significant. And whenever you're trying to publish papers and get tenure and like get a job and all that type of stuff, you have to publish papers with statistically significant results. That's kind of like how the system's set up. So like there's incentive to do a lot of data mining and a lot of stuff like that, right? Does that make sense to everyone in here, right? That like a lot of scientists might be like a bit off in what they're trying to do. Next thing, p-hacking. It's also called data dredging. This would be, and this kind of goes into the epidemiology faces its limits, like how we have like really fancy types of statistics and new ways of doing statistics. More or less, what it is, it's the misuse of like a statistical or data analysis in order to get a different type of result. Like there's an old saying that if you torture the data enough, it will tell you whatever you want to hear. Right? Has anyone ever like heard that with like, I don't know, like trying to get information out of people? Like, I don't know, like Jack Ryan, movie shows, whatever. Okay, no. All right, y'all aren't into this anymore. Sounds great. Sounds great. Okay, cool. But yeah, like that's really it. Hopefully this correlation stuff is like kind of interesting to y'all. So yeah, I guess we'll get out of class early. Is that cool? Do y'all have any questions about anything? Yeah. Here, let me just